What is up, students? I've mentioned the idea of a conceptual toolbox before, so I've gone ahead and created one with a focus on medium hard concepts on the SAT. So I know you're probably watching this video for the December SAT, so consider this a last minute kind of cheat sheet and some concepts to think about and focus on when you study this week. Okay, so I'm going to give some examples along with how to use the toolbox, and I'll link it as a Google Doc in the comments. How do we use this sort of toolbox? Like, what does that mean? Let's start here. First of all, SAT test makers have to stay within conceptual constraints when creating a question. This means they can only ask questions that can be solved with Algebra 1 or like Math 2-ish level skills or below. Now, that doesn't mean they can't make it really tough, because what they can do to make a question difficult is they can add complexity through multiple concepts, or they can make it to where the wording is tricky and figuring out which concept you're even in is tough, along with some calculation. So there's this sort of max toughness they can make it, but they can do it in many different ways. But they must do it with these sort of puzzle pieces, which are conceptual, are sort of topics, are equations, however we want to see it. I think of them as tools in a toolbox, but if some other word makes more sense to you, that's fine. I just have listed all of the relevant topics in one place. So it's like a little cheat sheet, but more so than that, I'm trying to teach you how to use a cheat sheet properly on a standardized math test. So how do we get into this mindset when we're taking the test? Well, we think, what topic does this problem have to do with? If you don't immediately know how to do the problem, and I'm talking like you see it and you know exactly what to put into Desmos and everything, you need to default to your structure. And that structure is, what do I know about that topic? If nothing clicks, if nothing in your sort of equation toolbox looks like what's on screen, try with a different topic or try with a different concept. If that doesn't happen, it might not be a problem you can solve. But if we know that, that helps us move on. So in either scenario, thinking about it from this sort of fundamental puzzle standpoint will really help you. So if you don't know what to do on a problem, it's really hard to just focus and be more intelligent. That's not going to happen on the test. So when you have this need for more, where do we go? We go to our conceptual toolbox, our set of concepts, these puzzle pieces that both we and the test takers are forced to use. Okay, in this problem, we can already start thinking about quadratics because it said so right here. So what does our quadratics toolbox cheat sheet actually look like? In an ideal world, we would have these concepts already floating around. We're very comfortable with them. So this is what it would look like. We start thinking about what connects to the question, and that vertex form is already looking pretty good. So we don't want to be lazy on the SAT math, so it's got to be a habit to quickly sketch any coordinate planes, vertexes, shapes, whatever it might be. We can start to see our vertex, visualize what it's going to look like at 4, -32. And remember, we have this vertex form right in front of us in this example, but on the test, you want to write it out to remember that the h gets subtracted just to, not get confused by any of that. The number is going to be 4, -32, the point rather, where the vertex is going to be. So if we visualize what the graph looks like, and if it also hits 0, 0, we can start to see where the other intercept is going to be. Since the vertex is in the middle of a parabola, the other intercept will be twice as far away at 8, 0. And just to double check we're answering the question and not some other thing, it is indeed t, the x part of the point that they're asking for, which is going to be 8. So you can see here how thinking of this in a conceptual toolbox mindset got us on the track really quickly. It might seem hand-picked, but let's look at a couple of other examples, and you'll start to see how in one way, shape, or form, the answer is going to have to do with one of these concepts. Okay, this problem might not immediately look like a quadratic, but we know it is one because it's in intercept form, first of all, but second, we know the leading term is going to be x squared. And when we start thinking about quadratics and we see this word minimum in the question, immediately we need to start thinking about the vertex. And how do we find the vertex? What's something in the toolbox that helps us find it? It's the -b/2a. And One thing I'll let you know is as we start multiplying this out, you'll see me not really pay attention to the c, that negative 14 times 19 part of the FOIL. That's because negative b over 2a doesn't involve c. So we're really just concerned with what b is going to be because we already know the leading term is x squared, a is 1. So we're just concerned with what negative 14x plus 19x is. We don't even have to think about that c. We don't really have to multiply out the negative 14 and the 19. So if we know that b is going to be 5, we know that the vertex is located at x equals negative 5 over 2. In this particular question, it's literally just asking for what value of x do we get the minimum. So the answer will be negative 5 halves, but occasionally they're going to ask for a different part of the problem. So just make sure that you're actually answering the question. Bonus tip. I always, again, advocate checking your work. See what happens when you plug this into Desmos. I bet you'll be surprised with how easy it is to get this answer. Or check it.
You're trying to be cool.